Hi everyone, my name is M.charan. I am from M.charan University, Andhra Pradesh. This is a project demonstration video for Emertxe Institute of Embedded Systems Internship. Firstly, coming to this internship, our project is washing machine project using PiximLab. And coming to the things I have learned through this internship is started through by basics of C programming language. This that is required for the embedded system. In this language, I learned about data types, loops, strings, and so many extra topics. Anusha ma'am also explained each and every topic in detail. And now coming to the next module, which was explained by Priya ma'am. In this module, I have learned so many things like difference between microcontroller and microprocessor, analog to digital converter, and vice versa. Writing and uploading embedded C code to microcontroller, and also power consumption and optimization, timers and counters, and the microcontroller that we used to build virtual washing machine in PiximLab, and also using MPLab code is PIC16F877A. The tools required for this project is PiximLab, MPLab, and Priya ma'am also explained each and every topic and concept with detail. And the main purpose of this project is to design an automatic washing machine using PIC16F877A microcontroller. This mainly focuses on multiple washing programs by interfacing tools like buttons, fan, buzzer, etc. This project is developed and tested using PiximLab. Tools we used mainly there are tools and peripherals we used for the designing of this washing machine project. Tools we used are MPLab and PiximLab, and also we used X8 compiler, which we will link with this MPLab IDE to compile the code which we will write in this application embedded C program, and also the PiximLab tool which we use to simulate the washing machine. This PiximLab inbuilt there will be many microcontrollers and microprocessors, and we have to select a particular microcontroller for the specific task we will do. And also we selected for this project we selected a microcontroller PIC16F877A, and the peripherals we used for this project is timer, CLCD, keypad, and many etc. And this is the main microcontroller we used, PIC16F877A. There will be 5 ports: port A, port B, port C, port D, and port E, and there will be 33 GPIO pins, and also there will be 3 inbuilt timers: timer 0, timer 1, timer 2, and also it will operate on 12 megahertz clock speed. And you can see the VDD pin, VSS pin, and also clock pins. These are the general GPIO pins, and also things that we can observe from this virtual machine project, washing machine project, is we are not using a real-time washing machine, rather than we are using a virtual washing machine through a microcontroller called PiximLab and MPLab IE. To on the machine we have to press switch 5, which is RB4. RB4 will be represented on the PiximLab. After the power is on, the washing machine starts rotating, which washing machine's fan starts rotating, which represents the motor in the washing machine. And to stop the program we will press switch 5, which is RB5, and also we use switch 1, which is RB0, to control the door status. Now let us watch the virtual washing machine running process in the PiximLab and MPLab IDE. I am opening PiximLab application, and also this is the PiximLab application. Here, firstly, after installing the PiximLab, we have to select the board that we will use for this project. Okay, in board we will select, there are many options like Arduino, Mega, Nano, Uno, breadboard, and also ESP32 dev kit and PigGenius. And for this project we will select PigGenius. And for after coming to the microcontroller, we will select PIC16F877. Then we can see this interface in the PiximLab. Here you can see there are many peripherals like CLCD, keypad, LEDs, timers, relays, fans, buzzer, and also this is power on and off switch. This is reset switch. And also this is the main microcontroller PIC16F877A. These are the two relays inbuilt in this PIC16F877A. This is the fan which represents the motor inside the washing machine, and this is the buzzer which indicates after the completion of the program that which will run inside in this washing machine. And to upload the code that we will run would have written in the MPLAB IDE, we have to firstly load hex. After uploading the code, we will select it will run automatically, the code will run automatically. I will open the MPLAB IDE, for example, showing the code that we have written inside MPLAB IDE during the online webinars. This is MPLAB IDE, this application was given by Microchip Industry, and also the microcontroller we used in this project, which is PIC16F877A, is also manufactured by the same industry, Microchip Industry. And when we create a new project in this my MPLAB IDE, we will select X8 compiler to link with this project, so that the system can understand the language what we have written inside this code, and then it will build the project and also produce the hex file which we will upload in this PiximLab. We have to install this X8 compiler separately. After opening this MPLAB IDE, the left corner we can see there will be some drop downs like header files, source files, important files. We have to write each and every code in those two sections, header files and source files. And in source files we have written a CLCD for code, each and every peripheral we have written separate codes. For digital keypad, for timer there are two files, ISR and timers.c. and also for the main program there are two files, washing machine function def and also main.c. and we will write the macros in the header files, which is clcd.h. These are the macros, and also for each and every peripheral there will be a header file which will be linked to this main program.c. for main.h, also for timers.h, and also washing machine. And these are the codes we have written. The main program is, I will show you the main program. This is the main program we have written, and for every function this is the main program. And I will show you how to build this project. Is on the top corner there will be a symbol of hammer which represents the building of this project. in that symbol you have to press that and build main project. After this you can see on the right side, build is successful, total time taken, and then loading completed. Now this we have to upload the file in this uh, PiximLab reload hex. Since we have already loaded the hex before, we have to now reload the hex. This is the reset button. Okay, now here we can see press key 5 to power on washing machine. Key 5, which means RB4. How I am saying that which key 5 represent RB4 is, we have to count from these are the switches we are using for operating this washing machine. This num keypad, we are not using this num keypad. We interfaced this whole complete washing machine, virtual washing machine in this PiximLab by using only this RBX, RB0, RB1, these switches, not this num keypad. Okay, this is switch 1, switch 2, switch 3, switch 4, and this is switch 5. I am pressing switch 5 to powering on this washing machine. Here you can see these blocks animation, like powering on the washing machine. For the animation of those blocks, there will be a specific and separate code for that animation. I will show you that animation code. This is the code for that animation, void power on screen. Here this is the characters that we are printing there, and this is the lines we are printing below the first block line, and also there will be inbuilt delay milliseconds function, and after the animation of both the powering on screen, there will be delay of 2000 milliseconds. Okay, after that blocks animation powering on the screen, okay, there will be screen of program screen, washing machine programs. To scroll down the options, you have to press switch 4, which is 1 2 3 4. Switch 4 means RB3. I am pressing switch 4, then we can see the scrolling of the options on the CLCD. Okay, I am pressing this, you can see the scrolling, the options are scrolling down. Okay, to select the particular program, I have to long press the switch 4, same switch 4. Okay, I am selecting stain wash. I am long pressing switch 4. After long pressing, you can see the CLCD screen will show water level screen. So here we have to select a particular water level for the program, stain removal water program. Okay, again to scroll down the options, we have to press the switch 4. Okay, I am selecting, for example, max. So long pressing the max option, which means I am long pressing the switch 4. Then you will go to next screen, which is start or stop. Okay, here you can see switch 5 to start the program, switch 6 to stop the program. If I press the switch 6, what will happen? You will directly go to the main program screen. For demonstration, I am pressing switch 6, which is RB5. See, we have already went to the main program screen, like programs rinse, dry, wash only, aqua store, daily, heavy, and etc. Now I am again selecting stain wash by long pressing the switch 4. After long pressing the switch 4, you will go to again water level screen, like auto, low, medium, high, and max. I am selecting max option. For selecting, we have to long press the switch 4. Now I am pressing switch 5 to start the program. Okay, now you can see that function is, first there will be 3 functions for this, which is wash, then after rinse, then after spin. Okay, the time taken to complete this program is 1 minute. You can see 1 minute and approx 30 seconds, like that. Okay, and also you can see the fan is rotating, which is representing the motor is rotating inside the washing machine. Okay, here we cannot represent the motor rotation in this Pixim lab, so we are representing the motor with fan rotation. And here you can see the side option for CLCD 16 by 4, which means 16 characters, rows wise, columns wise 16 characters and 4 lines, 4 rows. Okay, this represents the 16 by 4 CLCD LCD. And here you can see temperature 27.5 degrees Celsius, and the time taken count is reducing. There will be specific code for time reduction, which is timers.c and also asr.c. See here you can see time will be reduced, minute minus seconds. Okay, these are the specific codes for that time reduction function in the CLCD. And also here you can see switch 5 to start, switch 6 to pause. Here don't assume that switch 5 is to start the program, again the program. It is to resume the process if we press the pause button. Okay, I am pressing switch 6, which is RB6. Okay, here you can see the fan turned off, and also timer countdown also stopped, and also the washing machine program also paused for a time because I have pressed switch 6. Okay, to resume the program I have to press switch 5. Okay, I am pressing switch 5, which then you can see the fan will rotate and also the timer also will start countdown. Here you can see fan also start rotating, and also if I press switch 5, okay, the program is completed, remove clothes. Here you can see the buzzer ringing sound also, which means the indication of the program is completed and to remove the clothes. Okay, and now to demonstrate the door status situation in this washing machine. For example, I will select a particular program which is woolen or woolen. Okay, I am long pressing the switch 4 to select that woolen program. Okay, after long pressing you can see water level screen, like max, auto, low, medium, high. I am selecting high option. After high you can see start or stop. Okay, I am pressing start option, and I have already demonstrated the switch 6 option also, so I am pressing switch 5. Here you can see time is 21 seconds, program function is wash. Okay, to demo the door status, in the code we have written a particular button for interfacing the door, which is switch 1, which is RB0. Okay, RB0 means if now I am long pressing the RB0, which is switch 1, indicating the door is open still, close the door. If I remove the long pressing of the switch 1, it is representing the door is closed, the program will resume. See, if I am long pressing, door is open, close the door, the buzzer is also ringing, and also fan also stop the rotation. That means the complete program inside the washing machine had stopped temporarily. If I close the door, once I close the door, the fan will rotate, the buzzer will stop ringing, and the program will resume. See, and program is completed, remove the clothes. And this is the demonstration of each and every peripheral that we have used. Then these are the buttons to control on and off situation of every component on this Pixim lab board. This is the first button is for CLCD. See, this is like on and off button for the CLCD, and These are the port D to this port D. See, the LEDs are off when I am turning off this port D LEDs, and this is for port B. You can see the turning off and turning on this all these LEDs. These are the more switches, enable buttons pins for each and every component, and these are the two relays, and this is power and on and off buttons, and this is the demonstration of this washing machine program, and these are the main codes that we have already built and uploaded inside this PixSimLab board. Okay, now coming to the conclusion, in this project we have successfully designed and simulated a base virtual washing machine using PIC16F877U microcontroller, and the use of simulation tools enabled efficient debugging and testing of microcontroller code written in embedded C, making the development process faster and more cost effective. Using PixSimLab, we are able to test real-time operations without any hardware objects. Finally, project helped in understanding embedded systems. Thanks for Emertxe Institute for giving this amazing embedded systems internship.